Hello, you are welcome to Best Brain Academy. My name is Dr. Kingsley. In this class, I want to show you more questions on First Law of Thermodynamics. We can solve more and more questions to increase our experience. Now, if you look at the board, there is a question here. 1 mole of benzene is converted reversibly into vapor at its boiling point. The boiling point of the benzene is 80.2 degrees Celsius. By heating, the vapor expands against the pressure of 1 atm. The heat of vaporization of benzene is given to be 395 joules per gram. They say we should calculate number one, the heat absorbed, by benzene. The number two is the work done by the vapor. All right. Then the change in internal energy of benzene. Now, if you look very closely, you see that the quantity of heat that is to vaporize 1 mole of benzene has been given to us is 395 joules per gram. For what? For 1 mole of benzene. Then also we know that the molar mass of benzene is 78 gram. Molar mass of benzene is 78 gram. Therefore, number one, which is for us to find the heat absorbed. The heat absorbed should be equals to, of course, the heat for 1 mole, which is 395 joules, per gram, or we can use the other per gram that was given, per gram, then multiply by the molar mass, which is 78 gram. You see that this gram will cancel this gram, so that the quantity of heat that is liberated is 30810 joules of heat was liberated, to turn this benzene to vapor. Then number two says we should calculate the work done. So we are looking for work done. Remember, work done is equals to pressure multiplied by change in volume. And you know that from ideal gas equation that pressure multiplied by volume is equals to nRT. PV is equals to nRT from ideal gas equation. We can see that the number of mole given to us is 1 mole. They say 1 mole of benzene. So N is equals to 1. R is a constant, which is 8.314 joules. Joules per mole. Alright. Per Kelvin. Alright. So then the temperature given to us, T, is 80.2 degrees Celsius, but we have to convert it to Kelvin. That will be 80.2 plus 273, so that it will be in Kelvin. So the answer that we'll get, if we convert this to, it will be 353. That is 353.2, Kelvin, according to what I got in my calculator. Then you can now see that what the work done will be equals to nRT, which is 1 mole multiplied by 8.314 multiplied by the temperature, which is 3.2. So the work done, the final answer is 2936.5 joules as the answer. If you punch your calculator, I think you should be getting this. That is the work done. Then number 3, which is the final question here, they say we should find the change in internal energy. Remember, change in internal energy is equals to heat minus work done. Now in this case, remember, before benzene can evaporate, it must absorb heat. So the heat absorbed here should be positive. And also, the heat absorbed should be positive. And also the work done is also positive. So the change in internal energy, the E, should be giving me the Q minus W, okay, which is 30810, okay, minus the work done that we got, which is 2936.5, okay. So change in the internal energy should be 278, okay, 73.5 joules. According to the calculator, is 27, okay, 873.5 joules. So that is the change in internal energy. Subscribe to my videos, share and like. Thank you very much.